Alright, this is a quick video about tides. We're focusing on the position of the Earth, Moon, and Sun, and how those three things relate to one another in causing tides. So, focusing first on tides, we're talking about the periodic rise and fall of the sea level. Periodic meaning happening on a consistent basis in a timely manner. Here's an example of a high tide and a low tide. You see the same boat, the same dock, the same shore, a picture going from high tide to low tide. So again, it is a cycle, so we're going to have a repeating high tide and low tide. Alright, focusing first on the cause of tides. Okay, tides happen on a daily basis as well as they change on a monthly cycle. Focusing on the daily cycle, the main cause of tides is the pull of the moon's gravity. We need to remember that gravity is a force, and forces act in pairs. So just like the Earth applies a force to the moon, pulling it around us in its orbit, the moon also applies a force on the Earth. The most noticeable effect is that the moon pulls on the Earth's ocean, causing a tidal bulge on the near side. Now it also pulls on the Earth a little bit, leaving a tidal bulge on the far side. Alright, just so we're clear, this little white circle is the North Pole. We're looking at the Earth from above. The dark blue circle is the Earth, and these turquoise margins are a really exaggerated picture of the moon pulling on the oceans, basically pulling the oceans towards it, pulling the Earth towards the moon, and leaving another excess of water on the far side. So, as the moon does this, the Earth rotates. Okay? I want us to pretend that we are living somewhere on Earth marked by this green dot. Let's imagine that we live on a beach somewhere and that we live here at the green dot. As we rotate into a bulge and then out of a bulge, into a bulge and out of a bulge. When we rotate into a bulge, that would be high tide. We're rotating into an area where the water level will be higher, either because we're in a bulge. Now when we rotate into a low tide, that's where we're rotating into an area basically where the water is thinned out because it's being pulled to both sides. So in the bulges, those are our high tides. And then where we're not rotating into a tidal bulge, those would be marked by the low tides. So there's basically a changing tide every approximately 6 hours. If you think of one rotation being 24 hours, as we rotate, we'll hit a high, a low, a high, and a low. So that would be about every 6 hours in between. So there's two high tides, two low tides every day. They change on approximately every 6 hours, and moon phase does not matter. It doesn't matter where the moon is. The Earth is always rotating towards it or away from it. Okay, so now focusing on the monthly pattern. I'm sorry. Before that, here's just a way to visualize your high and low tide. So as we should note here that tides are not the same as waves. As waves crash on the beach, they're coming in and out. At your high tide, they'll be higher up on the beach. At low tide, they'll be further out. Okay? So a cycle every 6 hours from a high tide back to a low tide. Okay, now the monthly pattern. Tides change on a monthly basis because of the moon's phase. The strongest tides are called spring tides, and they occur at the new moon phase, where the moon is in between the Earth and the Sun, and the full moon phase. Now in either case, the moon is making a straight line with the Earth and the Sun. So remember this straight line here. That happens at the full moon phase and over here where the full moon would be, the new moon and the full moon. Now when those three bodies are in a straight line, the gravitational pull is stronger. Okay? Now with stronger gravitational pull, you get bigger tidal bulges. If you've noticed, I drew this bulge larger than I had before. So when you rotate into a high tide, that high tide is even higher. When you rotate into a low tide, that low tide will be lower. Now this will occur every 2 weeks because it takes 2 weeks to go from the new moon phase to the full moon. Again, highest high tides, lowest low tides. This will happen every 2 weeks. That is called the spring tide. It has nothing to do with the season spring. Now what that looks like is your margin between high tide and low tide, the distance between the two will be greater. If you imagine a marker in the sand at your high tide and a marker in the sand at the low tide, those two markers will be further apart, twice a month at the new moon phase and the full moon phase. So when the high tide comes in and the low tide goes out, those distances will be greater in between each other. Now in between, you have the first quarter moon and the full quarter moon. Instead of a straight line, you basically have a right angle between the Earth, moon, and sun. Now the gravitational effect here is a lot weaker. Because of that angle, you don't have the additive force of gravity when they line up in a straight line. They almost cancel each other out, and you have a weaker gravitational pull. So those tidal bulges are going to be smaller. Okay, I've drawn these a lot smaller than I have the first time. So when you rotate into a high tide, that high tide's going to be not so high. When you rotate into a low tide, the low tide's not going to be so low. This occurs at the first quarter and the third quarter. This effect is known as the neap tide. Okay, that's the neap tide in contrast with the spring tide. So again, every 2 weeks, a first quarter and a third quarter, you have a weaker gravitational pull that results in weaker tides. Your high tide to low tide this time will be closer together. So when the high tide comes in, it doesn't go up so high. When the tide moves out to the low tide, it's higher up on the beach than it was at the lowest point. So on this screen, we can compare the spring tides that I've drawn in red to the neap tides that I've drawn in black. So your crescents and gibbous moons are going to be just in between the two. So red is spring tide, that's full moon and new moon. Black is neap tide, those are your quarter moons. Alright, so we talked about a daily change in tides and a monthly change in tides. Daily is caused by basically just the gravitational pull of the moon, and the monthly tides depend on your angle between the Earth, moon, and sun. In a straight line, the gravity's stronger. Those are spring tides. At a 90-degree angle, the gravity is weaker, and those are called neap tides. And that will do it.